Hello and welcome to Martin Maths. We're continuing our preparation for Igcse, doing June 2013, paper 2, and this is question 5, and it's circle geometry. And so you need to know our circle theorems here. So if we look at this circle, we've got A, B, C, and D, all points on the circumference. O is the center, which is 130 degrees, and we've got to work out X and then Y. And DCE is a straight line. It's not a tangent, but it's a straight line. Okay, so the first thing that I'd do, I would construct A to some point here, let's call it F, and D to that same point. Obviously, I don't need to be accurate because it's not to scale, so I haven't even used a ruler. But then I can use one of my circle theorems, which is that the angle at the center is twice the angle at the circumference. So I know that that angle F is 65. Then I can use one of my other circle theorems about cyclic quads, so that AFDB, if I connect those and those, I've got a cyclic quad there, and 65 and X must add up to 180. So I've used cyclic quads, so I get X to be 115, 180 minus that 65. So X is 115. Okay, so I've constructed, used angle at the center, twice angle at circumference, and then I've used cyclic quads. So for Y, it's on the straight line, DC and E. Now, I can use another circle theorem, which is that angle subtended by a chord, or an arc, so AD subtends X and Y, X and ACD to be equal. So X and that point there are both 115. Then I can use angles in a straight line, add up to 180. So if I look at that again, angles in a straight line, 180 minus 115, and Y is going to be 65. So just to be clear, let's go through that again. For angle X, I constructed that, used angles at the center, twice angle of circumference, then used cyclic quads to add up to 180, got X to be 115. Then ABD, which is X, and ACD are both subtended by AD, so they're equal. So that point there, ACD, is also 115, and then Y is angle on a straight line. That's some Igcse preparation. Thanks for watching. Don't forget to like, subscribe, and share.